So today we're going to discuss section 9.2, which is characteristics of quadratic functions. So really our objective today is to find the zeros of a quadratic function and the line of symmetry and a couple other things that go with this, including vertex and things like that we're going to discuss in a little bit. So now what we're going to talk about is what is a zero. So zeros are what we would consider as being nothing, but what does that relate to when we're talking about a function? So a zero by definition of a function is as follows. And that definition is that any value of x that makes the function equal to 0. And so what this is saying is that when x is equal to some number, what we do is we substitute that value of x into our original equation, and it's going to give us y equals 0. So think about this as the input-output. As I input some number, it's always going to give me back 0, and so that's what a zero of a function is. So whatever number I input, that number is going to give me a 0, and so that x value is what we call the zero of a function. Now a function can have a couple different zeros. So a function can have either 1 0, it can have 2 zeros, or it can have no zeros. So depending on what the graph looks like and where the graph is located, it can either have 1 0, 2 zeros, or 3 zeros. And just a little side note, what we can also think of zeros of a function is what we would consider the x-intercept. So this is just another way of saying this is where our graph crosses the x-intercept. And so we talked about what we can have with linear, which linear will only have one intercept at a time, where with a quadratic though, it will either cross one time, 2 times, or no times at all, and we'll see what those will look like. So the first thing that we can do is we can find zeros graphically. And basically the way that we want to find zeros graphically is to first find the point on the x. So what we're doing is we're finding the point on the x-axis to where it crosses, and then what we're going to do is we're going to plug that into our original equation and see if it truly is a 0. So if we look at this first example, we can see that this graph crosses the x-axis once and twice. And over here, the x value that it crosses at is x equals 3. And what crosses over here is x equals -1. So basically what we're going to do is we're going to substitute these into our original equation and see if it does give us 0. So if we do x equals -1, we do y equals -1 squared minus 2 times -1 minus 3, and that gives us 1 minus -2 minus 3, and we know that this is going to give us plus 2, and so we can say 1 plus 2 minus 3 does give us 0, so that one works. And if we try the next one, x is equal to 3, we do the same thing. Y equals 3 squared minus 2 times 3 minus 3. This gives us 9 minus 6 minus 3, and we can see that 9 minus 6 is 3, minus 3 more gives us 0. So both of those are indeed 0. So this is an instance where we have 2 zeros because it crosses the x-axis twice. So 2 zeros. So the next one, if we look at the next example, what that's showing us is that it crosses just once. And this one is a little bit unique. So if we ever see a graph that crosses the x-axis just once, this is also too what we know as the vertex. So if for some reason it only crosses once, that's also the graph's vertex. And so if we look at this, this is where x is equal to -4. So let's go ahead and try this one. So y equals -4 squared plus 8 times -4 plus 16. So we get y equals positive 16 plus -32 plus 16. Our commutative property lets us add in any order, so we can say 32 plus -32 and we can see that y is equal to 0. So when y equals 0, that's when x is equal to -4, so we say that -4 is a 0. And like I said before, we can see this only crosses once, so this gives us 1, 0. In our last graph, if we look at this graph, here's our x-axis right here, and it doesn't even touch it at all. So we can say here, very easily and very straightforward, that the zeros here is that there are no zeros. So no zeros. So this never crosses the x-axis. You can see this opens downward. And so since it's below here, since our y is -2, this is never going to cross the x-axis ever. And so we can say that there are just no zeros in this equation. And now that we know how to find zeros, what we can do is now we can take this and kind of apply it to our axis of symmetry. And so now what we can do is we can find our axis of symmetry, and what we know about our axis of symmetry is that it's always going to pass through the vertex. So if we ever have a graph, we can try to find the vertex of our graph, and then what we can do is we can use that vertex to draw a line of symmetry. Now, if I tell you that it passes through the vertex, what we need to do is that we can draw this kind of imaginary line in this first example where we have 1, 0. And so basically when we have 1, 0, the x coordinate of vertex is our line of symmetry. Because we know that this 0 right here, when x equals 3, that's our 0, that's our 1, 0, that's also our vertex. And so it passes through the x coordinate of the vertex, and we can describe this line by the equation x equals 3. Because if we remember anything about our straight lines, a horizontal line is y equals something, but a vertical line is x equals some number. And so this line right here is x equals 3. And that also is our line of symmetry. Now when we have two zeros, what we can do is, sure, we can go here and we can find our x coordinate of our axis, which is ending up being x equals 1. But what we can also do is we can take the average the x of the zeros. So we can find our 0. So if we for some reason can't find out because our graph is a little off or anything like that, what we can do is we can find the x value of each 0. So this one ends up being x equals 3, and this one ends up being x equals -1. So what we can do is we can find the average of these two, and that will also give us our vertex, or not our vertex, but our line of symmetry. So if we do this, we have -1 plus 3 divided by 2, that's our formula for average, which gives us 2 divided by 2, which is 1. So x is equal to 1. This is also describing the line that goes through there. So if I get rid of some of this stuff over here, we can see that this is our vertex here, and our line of symmetry is going to go right here, and that's described by the line x equals 1. So we can do this one of two ways. With 1, 0, it's the x coordinate of the vertex, or the x coordinate of our 0. And when we have two zeros, it's the average of the x's, the x values of the zeros. So if for some reason we can't easily see the vertex, we can also just average the two zeros, the x values of the two zeros, and find out that line too as well. Now what happens when we don't have a 0 and we have a really bad graph? So what we need to do is we remember our formula for standard form, and what we need to do is we need to find an equation in standard form, or if we don't have our equation, we need to put it into standard form, because sometimes we cannot easily identify the vertex, and we can't easily identify the zeros, or if there are plain no zeros, because the graph is never going to cross the x-axis, so we can't take the average of the x's if we don't have them. And so what we have is we have this handy formula that we can use, and that formula is as follows. We have x is equal to negative whatever our b value is in standard form, so b divided by 2 times a. So whatever our a value is in our formula, or our standard form, we use that along with b and use this little formula that says x equals negative b over 2 times a. And so what we can do is we can look at these two equations and easily identify what our x value is so that we can use that to describe our line. And so if we say, okay, what is a in this equation and what is b in this equation? Well, a is the number out in front of the square, which is negative 3, and b is the coefficient of the plane x, which is 10. And so we can just plug this into our formula and say x equals negative b, which is 10, divided by 2 times our a, which is negative 3. I'm going to put those in parentheses. And so what we come up with is we have x equals negative 10 over negative 6, which this happens to be negative times a negative, which is a positive, 10 over 6. And so with 10 over 6, we end up getting 5 over 3. So our line for this equation ends up being x equals 5 over 3. And so now this is what we're talking about, is you can't easily identify on a graph 5/3 or basically 1.67. There's no way that you would be able to figure that out if you hadn't looked a little closer or tried to use a calculator or any kind of graphing software. Now if we look at our other equation, we do the same thing. A is equal to 2. B here is the number out in front, which remember we have that implied 1, so b is equal to 1. We plug this into our equation, or our formula, and we get x is equal to negative b, which is 1, over 2 times 2. And as we simplify that, it gives us negative 1 over 4. And so x is equal to negative 1 over 4, which again isn't an easily identified line, and so that's why we can use this formula to figure this out. And now what we can do is we can use this same idea to continue to find the vertex of any graph. Now I have a graph here because first we can easily see where the vertex is, which is about here, but this is just to use to verify. So what we can do is we can use the same formula of negative b over 2a. So we can use that same formula to find the vertex. Then we substitute that x value back into our original equation. So back into our original equation, and what that's going to give us is that's going to find y for us, and then what we can do is we can create an ordered pair from that. And so this is how we do that. So first of all, we need to find x. So x is equal to, well, in this case, a is 0.25, b is equal to 2. So x is equal to, move this here, x is equal to negative 2 over 2 times 0.25, and so that gives us negative 2 divided by 0.5, which when we divide that, that gives us negative 4. So we have negative 4 is equal to x. We plug that back into our original equation here, everywhere we see x, and so we plug this in, we get y equals 0.25 times 4 squared, or negative 4 squared, I'm sorry, plus 2 times negative 4 plus 3, and so that's going to give us 0.25 times 16 plus negative 8 plus 3. And so now what we're going to do is I'm going to move this just a little bit. And so 0.25, or 1/4 times 16, is just 4 plus negative 8 plus 3 is going to give us a final answer of negative 1. And so we can look at this and say, okay, what is this point anyway? This point is -4 comma -1, and our value for x is -4, our value for 1. So our ordered pair from what we found is also -4, -1. And so basically what we did is we just found the vertex, and we verified it up here. So basically all we have to do is use this formula for x, substitute it into our original equation, find our y, which we've done before. We can substitute and find a value, and then create the ordered pair, and that's going to give us our vertex. And so now we can easily find our line of symmetry, because we know the line of symmetry is just our x value, because it has to pass through the x, or has to pass through the vertex. So this value is x is equal to -1, or I'm sorry, -4, and so that's our line of symmetry too as well. So the last thing that we need to look at is a couple examples of how to find the line of symmetry in the vertex. Now if we remember on how to find the line of symmetry in the vertex, it's kind of one and the same. So the first thing is we just need to find the vertex, and if we find the vertex, we know the line of symmetry will go through that. And so we use our equation to find the vertex, that x equals the negative of b over 2a. So really all we have to do is find a, find b. So a here is -3, b is 6. So we use our equation, x equals the negative of b, which is 6, over 2 times a, which is -3. And so in this case we get is equal to -6 over -6. Negative and a negative gives us a positive, so we get 1. So in this equation x equals 1. So now what we need to do with this x equals 1 to find the rest of our vertex is put this back into our original equation here, and we see that y equals -3 times 1 squared plus 6 times 1 minus 7, and we get -3 times 1 plus 7 minus, or not 7, plus 6 minus 7, which is equal to -3 plus 6 minus 7, which gives us -4, because -3 and -7 give us 10, -10, and then add back 6 and we get -4. So y equals -4. So our ordered pair for our line of symmetry is as follows: 1 comma -4. And then our equation for our line of symmetry is just x equals 1. And so this here is our answer. Now if we look at the other example here, we do pretty much the same thing. So a is equal to 1, b is equal to -4 here, and so x equals -4 over 2 times 1, which negative and a negative gives us a positive, so we just basically have 4 over 2, which is equal to 2. So in this case, x equals 2. We plug this back in our original equation. Y equals 2 squared minus 4x, which that x is now a 2. So substitute our 2 in. So times 2 minus 10, we get 4 minus 8 minus 10, which gives us order of operations, shows us 4 minus 8 is -4. So -4 minus 10 gives us -14. So in this case, y is equal to 14. Our ordered pair for our vertex is just our x and our y. So we have 2 comma -14, and our line of symmetry is simply just x equals 2. And again, we know that because of the fact that our line of symmetry goes through our vertex, and it's whatever that x value is. The last thing that we're going to look at is just a couple of things to remember. Remember, the line of symmetry goes through the vertex and is equal to the x-coordinate of the vertex, and is written x equals something. That's our equation of the line. The next thing, so that's the equation of the line. The next thing is that we find the x-coordinate by using the formula x equals negative b over 2a, and then the zeros of the function are where the graph crosses the x-axis and where y equals 0, and so it's kind of like an x-intercept, and there can be three options. There can be 0, there can be 1, or there can be 2 different zeros. So if you want to go through and look at the guided practice problems and just do a variety of those, you can get a pretty good understanding of what they're asking you for.